My name is Mark Pettis, and I'm the semiconductor editor of VID00011, and I'm here at the Computer History Museum in Mountain View, California, after a press event with Expansion. And to my left is Bertrand Cambu. He's the president and chief executive of Expansion. They're the world's largest supplier of NOR flash memory. And we were at a very interesting press event here today, and the company talked something about echo. And can you give us an idea of what is echo RAM and how does this change the landscape in the data server field? Is that right?
Yes, that's right, Greg. Thank you very much for covering our event. This is obviously a key day for us, and we have been working now for a couple of years developing a brand new memory architecture specifically aimed at search engine. And in this particular case, what we're trying to cover is instant search and compare with existing technology, cutting almost by order of magnitude the power and increasing also the capacity. And this is absolutely essential technology. The search engine of the futures are getting bigger and bigger thanks to the success of the search engine and the web.
So correct me if I'm wrong. It's going to be a DIMM that's going to perhaps go on a server, but you're not replacing the DRAM, shall we say, in a data center. Is that correct?
Well, we're going to replace the DRAM for some of the new server, and in those new servers is going to be a combination of EcoRAM and DRAM, and the combination of us is going to give those power advantage. To put things in perspective, in the current search engine, the size is the size of a stadium. It is humongous, and the energy that is being consumed in those data centers is again enormous. And by using EcoRAM, we're going to be able to cut the power and improve the capacity that we can put on each of those centers, which means that the answer is going to be a combination with existing technology, and we expect to achieve those results.
Now, let me ask you, what is the problem in today's data center? And this will change what for the data center communities, shall we say?
Well, the problem you have is the existing memory technology need to be refreshed every millisecond. Don't retain information. And it's essentially because of the power is very high, you cannot stack it too much, because then you're going to have ventilation problem. By having a technology that is essentially low power, not only you cut your utility, but also you can put more on the same square foot, which means that essentially the power and the integrations is what we are improving. Now, going forward, those databases are getting bigger and bigger because they are very popular. And in the past, those technology was good enough, but going forward, this is where EcoRAM, we think, is going to be pivotal and is very important segment of the economy.
Okay, switching gears for 1 second, there's a new competitor on the block called Mnemonics, and they've been talking about something called phase change memory for a long time. And you mentioned to me that this doesn't seem to be die sizes are big. Can you elaborate whether phase changes also will change the landscape or not?
Well, obviously every technology has their own field of use. And to my understanding, our competitor, phase change memory, is currently aimed at small density. For the search engine, we need huge capacity, which is not a technology that is provided by that phase change memory. And as far as what is the field of use of a PCM, I recommend you to talk to my competitor here, and they're going to obviously enlighten you. But this is not an area that our company is currently aiming at.
Last question. In the past, NOR has been behind NAND and SCADA, Is that still the case? And where will NAND be, or NOR be in the future, and will it ever run out of gas?
Well, to be accurate, or eco-RAM technology is transcending the NOR and the NAND, because we need a flash technology, a technology that retains information, but a technology that provide instant read for instant access, but also we need to update those databases much faster than the NOR, which means that our technology is kind of an hybrid between NOR and NAND. We're calling that technology mirrorbit, and that technology is currently adopting the NAND technology node migration roadmap, and we are kind of looking at essentially closing the gap. And because essentially mirrorbit is a planar technology that is fundamentally shrinkable, we believe that we are going to be very, very close to that roadmap. In particular, we are currently in production some 300 millimeter wafers at 65 nanometer. We expect sampling of 45 nanometer in the next few months to be in production in 2009. We expect to sample 32 next year and to be in production in 2010, which means that our roadmap is probably within a quarter or so of other flash companies going forward.
Thank you very much for your time. It's been a pleasure today, Sue.
Thank you.